Everything you ever wanted to know about the unit circle in one TikTok. We have a graph with the ones marked. Draw a circle with radius 1. Introduce a 45, 45, 90 triangle. The radius will be equal to 1 because that's the radius of the circle. And this will be an isosceles triangle since both these angles are 45, so we'll call these two sides the same value a. Since it is a right triangle, we know that a squared plus a squared equals 1 squared. A squared plus a squared is 2a squared, and 1 squared is 1. We can divide both sides by 2. The left side just becomes a squared, and the right-hand side is 1/2. Square root both sides. The square root of a squared is just a. We can split the square root up. Square root of 1 is 1. And then we're not supposed to have a square root in the denominator, so we can multiply top and bottom by square root of 2. 1 times square root of 2 is square root of 2, and square root of 2 times square root of 2 is square root of 4, which is 2. Both of these a's are equal to the square root of 2 over 2. And since we go to the right this far and up this far, this point would be root 2 over 2 comma root 2 over 2. And then we rotate 45 degrees to get here, so we label this 45 degrees. We can draw a congruent triangle in quadrant 2. The only difference is that the x would be negative root 2 over 2 because we're going to the left. Since this rotates 135 degrees, we'll label this 135 degrees. We can draw another triangle down here. The x and the y will both be negative, and we're going 225 degrees. And then we have the fourth triangle over here, which is 315 degree rotation. Next, let's draw a 30, 60, 90 triangle. The radius is equal to 1, and the height is 1/2. We don't know this yet, so we'll call it b. This plotted point will be b comma 1/2. The Pythagorean Theorem tells us 1/2 squared plus b squared equals 1 squared. 1/2 times 1/2 is 1/4, and 1 squared is 1. If we subtract 1/4 from both sides, the left-hand side goes away, and 1 minus 1/4 is 3/4. We can square root both sides of the equation. The square root of b squared is b, and we can distribute the square root, and square root of 4 is 2. So b is equal to root 3 over 2. So we can change both of these b's to be root 3 over 2. And this is a rotation of 30 degrees, so we'll label this 30 degrees. We have 3 more of these 30, 60, 90 triangles. We can label the xy points for these, and this one's 150 degrees, this one's 210, and this one's 330 degrees. Here are 4 more 30, 60, 90 triangles, so we can label those 4 points and the corresponding degrees for them. And last, we have these 4 points on the axes, and to get here, it's just over 1 up 0. And then for this one here, we go 0 right and up 1. And then these two are just the negatives of those. And now we've built out our unit circle. So what are we going to do with this? So here's a general case of one of those right triangles. If we call the central angle theta, the side opposite the theta is opposite. The side adjacent to the angle we call adjacent, and this side we call the hypotenuse. So we have trig functions defined by the ratios of these sides to each other. So looking at this 30, 60, 90 triangle, the opposite is 1/2 and the hypotenuse is 1. That simplifies to 1/2. If we look at the cosine, the adjacent is root 3 over 2, the hypotenuse is 1, that simplifies to root 3 over 2. And this is always going to be the case. The first value will always be the cosine of that angle, and the second value will always be the sine of that angle. It gives you a collection of cosines and sines for standard angles. I currently have 1954 subscribers on YouTube. I'd love to hit 2,000 sometime soon. If you want to send me some love,